Now, with human beings specifically, you have two different forms of melanin that we can find that specifically deal with the production of pigmentation in the skin and hair and all the things on our body that produce color. You have eumelanin, which gives you your black to brown pigments, and you have pheomelanin, which gives you your yellow to white pigmentation, specifically in the skin and the epidermis. As far as melanin itself, we know it to be this black or dark substance found in everything. Stuff that we find in human beings and animals and the neuromelanin in our brain, all of it is basically this black, dark substance that science has coined melanin. Now, pheomelanin is actually lighter than eumelanin. When you look at a pheomelanin cell and you compare it to a eumelanin cell, the pheomelanin cell is significantly lighter than the eumelanin. In fact, pheomelanin actually has its own unique cell structure that separates it from eumelanin. But again, looking at melanin, we can look at melanin and we can see that melanin is made up of all of these different elements. But out of all of these elements, the most prevalent element we find in melanin is carbon. And we know all elements come in three different forms, either as a gas, a liquid, or a solid. And when you look at carbon in its solid form, you'll see that it's a dark black substance, just like melanin. So from this, we basically got to conclude that the thing that's making the melanin substance as black or as darkly pigmented as it is must be carbon. And then in turn, you got to think, if carbon is responsible for bringing out that black pigmentation in melanin, is carbon also responsible for the darker shades of pigmentation we see in human beings? We know melanin is the key to our different skin pigmentations as human beings. But again, looking at all these other elements, hydrogen, nitrogen, oxygen, carbon literally is the only element out of all these elements that would seem like it would really play a key role in creating the darker pigmentations that we see across the board in human beings. Now again, carbon is black. It's a black substance. But what is black? Now, of course, we have our primary colors because we find all these colors in a rainbow. You can also find all of these colors in rays of light. And each one of these colors correlates with a specific element found on the periodic table and found in our sun, in the human body. Now, from three primary colors, red, blue, and yellow, you can get brown. You can mix these three primary colors up in different combinations and get different shades of brown, lighter and darker shades of brown. So you mix yellow and red together and you get one shade of brown. You add blue and you start getting some deeper, more defined shades of brown. Then you can even start mixing two different browns together, and that leads to even deeper, darker, more defined shades of brown. But doing all these separate combinations of the primary colors and the brown shades is always going to lead you to a different shade of brown. But you will never quite get black from mixing all these small combinations of colors together. You can try different small combinations of all these primary colors, mixing them together, and you will always come up short of getting black. The only way you can get black is by mixing every primary color together. So when you mix red, orange, yellow, green, blue, indigo, and violet all together, you're going to find that you will get black. Black is literally a combination of every single primary color. So when we see the color black within our visual spectrum, what we think we're seeing as black is actually every single primary color all combined as one. And you got to remember, the sun and stars in general emit a spectrum of different color lights. And each one of these colors correlates with a particular element on the periodic table. And black absorbs light. Black is the absorption of light. And again, we have all of these elements radiating within the spectrum of light. So when we see black, we're actually seeing the absorption of all colors, the absorption of all elements. Now again, carbon in its solid form is a black substance, a dark black substance. And our very own complexions found in human beings most likely comes from these carbon atoms we find in the melanin cellular structure. So the next question is, what is carbon in its purest form? What would that look like? What does that look like? So yes, Vanta Black is basically carbon, vertically aligned carbon nanotubes. Is basically carbon molecules bonded together in this cylinder form. So we have a bonding of carbon atoms to create this material known as Vanta Black. And we have a bonding of carbon atoms obviously in the solid form. So we're seeing solid carbon bonded together, and what that should look like, or what that does look like in its native form. This is just pure carbon atoms bonded together, and what they will look like on the surface in a physical form. The first thing you're going to find is that Vanta Black is considered the blackest known substance on Earth. They say it absorbs about 99.965% of all visible radiation. So it absorbs almost all light rays around it. Any visible light surrounding this thing in its small little vicinity that it's in, it absorbs that. And again, remember, with the color black, the reason we see black as black is because it's absorbing all of this light, all of these different color light rays. All color in the visible spectrum is being absorbed by this color known as black. And again, this is simply just carbon atoms bonded together to create this coating of pure carbon, pure solid carbon on the surface. And again, you got to think, with carbon being the most prevalent element found in melanin, and the only element in melanin that we know could produce the dark pigmentation that we see in human beings. So it just makes you think, what would a human being who contains that pure melanin polymer with that pure coating of carbon covering their bodies, what does that human being look like? I don't think we've seen it. I know we see what we perceive to be a lot of black people out there, but when you really look at these people, are they black or are they just darker browns? I haven't seen a human being on planet Earth that is to this point of carbonation on the surface level. Now, none of us, as far as I know, again, were there to see the original human beings, or what we would perceive to be the original human beings. If there was even an original, we don't even know how far this thing goes. But just based off of what science is telling us, and scientifically, it would seem like what we would have walking around is human beings that were extremely carbonated, on a level that we probably couldn't even wrap our heads around. And when you look at what pure carbon can do, again, you got to think, somebody with a high quantity of this stuff we call melanin, which would also give them a high quantity of this stuff we call carbon. Just exactly what type of human beings are we dealing with? Now, if you accept that this is what the original human beings look like, that this is what the original human beings were, then you've also got to accept that anything below that, any skin tones that we see on planet Earth right now below this original purely carbonated form, would have to be a lesser version of these original human beings. And just like when you look at the color black and it being an absorption of all colors, when you look at the color white, it literally is the reflection of all colors. So when we look at white, we're actually looking at black turned inside out. Rather than all those colors being expressed inwardly, white is an expression of all those colors outwardly. All those colors are being fleshed out. So looking at that huge variation from black to white, anything in between that would be a lesser degree of this same fleshing out of these colors or these elements. And of course, they tell us melanin itself is made up of these elements: carbon, hydrogen, nitrogen, oxygen. But how did these elements begin to be fleshed out of the human cellular structure? Remember, with the basic science, in order to get brown, you have to eliminate something. Otherwise, you're going to always end up with black. So something had to be eliminated from that melanin polymer in order to create brown. And then from there, you go down the line. And when you look into science, you're going to run into something called the MC1R gene. And this MC1R gene is responsible for making a protein known as the melanocortin 1 receptor. And this receptor is basically like the most important factor in producing different pigmentation in human beings. It sits like right on the surface of the human melanocytes. Basically, when this receptor is active, it causes the human melanocytes to produce eumelanin. When the receptor is inactive, or when it's blocked, the melanocytes form pheomelanin. So you got to think, what caused this receptor to be shut down or blocked in the first human beings who produced pheomelanin? And when you look at the eumelanin chemical formula in comparison to the pheomelanin chemical formula, you're going to notice that everything is exactly the same. You got carbon, you got hydrogen, you got nitrogen, and you got oxygen. But the one major difference within that pheomelanin chemical structure, sulfur. Sulfur is the one element that separates eumelanin from pheomelanin. And what you will find is that when you combine carbon and sulfur together, you get what's called carbon disulfide. And what happens is that sulfur starts to dilute carbon. And with the combination of the sulfur, the carbon becomes colorless. And I mean, if you don't think it's anything more than a coincidence that the one element needed to dilute carbon is found in pheomelanin, which we're being told is a fairly new melanin polymer structure that was introduced in the last 8,000 years, then I just don't know what else to tell you. But to me, this sounds nothing like some type of spontaneous mutation. This sounds like something that was deliberately executed. And then I know some of you are thinking, and you're going to say, well, okay, that's how we got pheomelanin, but how do we go from this pitch black, pure carbon to the brown skin tones? Well, that's when you get into what's called TPC2, which TPC basically stands for two-pore channel. And that's dealing with the cells within your body. Each cell within your body has these channels, these two-pore channels. Literally is what it sounds like. It's two pores, two different elongated pores that poke into the cells, and they send ions made of calcium and sodium in and out of these cells in different directions. So literally, you could probably just say two-pore channels, or TPC2, is like fuel for your cells, for your body's cells. And every single cell in your body depends on these two-pore channels, this TPC, in order to thrive, in order to function normally, including your melanocyte cells. And what they have found is that when TPC2 is disrupted, it causes changes in skin pigmentation, because it can begin to affect the pH levels within the melanosomes, and it basically can cause those melanosomes to start shrinking because, again, they're not getting enough fuel. And it's very likely that the manipulation of these two-pore channels connected to the melanosomes being manipulated could have been what caused the variation from that original dark carbonation down to the brown and so on. Remember, with black, you need it all. With brown, you have to eliminate something. This is just basic science. You cannot get brown without eliminating something. I know a lot of people think that we started out black and brown on this planet, but it just doesn't make sense from a biological standpoint, from a scientific standpoint. And looking at all of this scientific evidence, anything other than that original black is also a result of the manipulation of that original melanin polymer. So everything down the line, brown, red, yellow, white, all these other skin tones are all genetic mutations of the original black human beings. When you actually look at the molecular formula for melanin, you can see that. So you got carbon, hydrogen, nitrogen, oxygen, all this stuff coming together to create this dark black substance known as melanin. It's interesting because, as we know, the combination of these elements is basically the building blocks of life itself. They say that almost 99% of the human body, or the mass of the human body, is made up of just 6 elements. And out of those 6 elements, you have oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. 4 of those can be found in the structure of melanin itself. So 4 of the major elements said to be responsible for literally composing the human body, bringing the human body together as we know it. 4 of those elements can be found in melanin. So you would have to think that somebody possessing a high quantity of this stuff we call melanin, this dark black substance, somebody possessing a high quantity of this stuff would have to, by nature, be a more biologically advanced human being than a human being who doesn't necessarily possess this substance in as high a quantity. I mean, you got to think the human body is said to be made up of all these atoms that come together, millions upon billions of these things. So we have like a countless amount of atoms in our body that come together and they form these molecules that bond together to create these elements within these cells, which become the foundation for these cellular structures throughout our body. And literally every single part of our body is made up of these cells. Every single part of our body has a cellular structure to it. Now we know that all of these cells come from different elements. These basic set of elements come together to create these cellular structures and to form all the aspects of the human body that we see. But at the core of all of this, just in between the atomic level, we have these elements. And then we look at the stars, and our very own sun, our very own star, also carries these exact same basic elements. So you got hydrogen, oxygen, carbon, and nitrogen all wrapped up within this ball of gas called the sun. Then you have human beings already being made up of all these elements, which are wrapped up into these things we call cells, which are constantly regenerating on their own. But then we have the sun beaming down radiation, which is basically a gas form of these elements being sent through the atmosphere. So you got to think, if you have a human being already on the natural cellular level being made up of all these elements, and then this same human being also has an extra layer of these elements in the form of this thing we call melanin, then on top of that, they have this object called the sun, this star that's radiating these elements. You got to think, exactly what type of human beings are we dealing with?